Okay, question 10, factorise fully. So when we factorise, we would always take a common factor first. I can do that. If we've got a quadratic, we're looking at doing our trinomial factorising. This is a cubic, so we have to do our synthetic division, right? So the first thing I would do is set up my table. And I don't usually write this, but I'm going to write it this time. This is my cubes. This is my squares. This is my x's. Now technically this is x to the 1 and then x to the 0, which is just the units, isn't it? So what's my x cubed? It's 6. What's my x squared? It's negative 13. What's my x's? I don't have any x's, and then that's 4. And that's the only reason I've done it this time, because there's a little gap. You might want to always do that. That's totally up to you. Whatever makes you feel comfortable. The point is, if you don't have it, say there was no 4 there, I'd still have to put a 0 here as well. Okay, so just watch out for that. So that's an interesting one. They'll maybe try to catch you out with that. Now we're trying to factorise it. Now usually they say show something as a factor. They've not done that, so a bit of trial and error. They're not going to be mean to you. Okay, it's going to be like 1, 2, or 3, or negative 1, 2, or 3. The numbers you're looking for though are going to be factors of this last number. Okay, so it's going to be a factor of 4. So it's going to be 1 or 2. It won't be 3. So like I would just start off with 1. All right. So what do? We pull this one down to give us 6, and then we're multiplying and adding. So 1 times 6 is 6. Take away 13, it's going to be negative 7. Multiply it for 7. Add it. Multiply it. Nope. Okay, so that's 11. So 1 is not a factor. Okay. Let's go again. So I've got 6, negative 13, 0 and 4. Let's try negative 1. So let's bring the 6 down. Okay, let's multiply negative 6. That's going to be negative 19. Multiply it for 19. Add it. Negative 19. Nope. So that's negative 15. So no joy there. Okay. Let's try 2. And we're thinking it's going to have to be 2 or negative 2, unless I've made a mistake with my tables. So bring the 6 down. So let's multiply them 12. That's looks more promising already, isn't it? 12 take away 13, negative 1. Multiply them for negative 2. Add them. Multiply them. There we go. 0. Fantastic. So that's my first step complete then. So I can say, and you don't have to, you don't usually have to write this. For this, I don't think you have to write it. For the other questions, you would have to say, but I'll say the full thing anyway. I'm just going to say the remainder is equal to 0. So therefore, x take away 2 is a solution, is a factor, sorry. Is a factor. I think for this question, we probably don't have to write that, but I'm going to write it anyway. So what that means is I can rewrite this equation with my x take away 2, because we changed the sign in there. What I'm actually putting in here is the actual root of the equation. So I know this has now got a root at 0.2. And what's left over is this bit here. So that's 6x squared, take away 1, take away 2. And I'm factorising it fully. I'm going to put that equal, so I'm putting equal to 0. So that's my next bit. I've just come from here, and that's that. So now I need to factorise the 6x squared. So for that one, I'm looking for numbers. Oh, sorry, the x in there. Numbers that add to the middle number, the negative 1, and multiply to these two numbers multiplied together. So my factors of negative 12 can be 1 and 12, can be 2 and 6, and 3 and 4. So 3 and 4 are looking good. I think to get negative 1, it's going to be negative 3 times 4. Yeah, and that will give me a negative 12. Yeah, so these are all, one of these would have to be negative. So you'd say it's negative 6 and negative 12, or you would do the exact same thing, exact same list, but make the other number negative. So negative 1, negative 2, negative 3. Okay, so I'm saying, yep, it's going to be this one. And then I'm going to break that apart. So I'm going to say I've got 6x squared negative 2, but in the middle now, this is negative 4x plus x. So that's just me rewritten this, plus 3x, sorry. That's me rewritten this based on those factors. And then we draw a little line. We're going to take a common factor. So I'll take a common factor out of 2x. So that's 3x take away 2. Then we rewrite our bracket and we say, what do I have to put in front of that bracket so that it would multiply it to give me this? Well, in this case, it's very easy. It's just 1, isn't it? Equals 0. And then we put these together. So I put this together with this. So that gives me 2x plus 1. And I just write my other bracket down. 3x take away 2. So that's the algebraic way of doing it. Some people do it trial and error. That's the way I do it. So I now can say that I'll just write the full thing out actually. But no, I'll then say that that's the same as saying x take away 2, 2x plus 1, and 3x take away 2 is equal to 0. That's my factorised version. Okay, so that's factorised fully. If I couldn't factorise this, I'd have to do b squared minus 4ac and say that b squared minus 4ac is less than 0, therefore that can't factorise, and then that's your final answer. If it wanted me to solve it, which is not asking me to solve it, if it did, I would be saying that x is equal to 2, x is equal to negative a half, and x is equal to 2 over 3. And I'll rub it out just now. That's how I'm going to solve it. And what that's telling you is the roots of the equation. Oh, can I go down a bit further? There we go. Thank you. Me and my basic computer skills. What that's telling you is the roots are at 2, negative a half, and 2/3, which would be, if I'll do that, it's 2/3. And that's your 2. Okay, so that's your roots. Now I don't know if it's doing something like, I don't know if it's doing that. I don't have enough information. It could be doing that. It could be doing this. You know, I don't have enough information. I just know that's the roots. If the brackets are the same, I know it's a repeated root. So if I had brackets that were, you know, say I had something like, you know, x take away 2 squared and x take away 5, I would know that I've got a root on 2 and a root on 5. I would know that the root on 2 is a repeated root. It's doing something like that, or it's going the other way. It's doing something like that. Okay, so just, you know, watch out for the sketching as well, and just think about what you're actually doing. So the solving takes it to actually working out the roots, but the factorising is enough just to leave it at this point. So let me just check the marking scheme for question 10. Yeah, absolutely, that's fine. So you're getting your mark for, or 2 marks for the synthetic division, and then 2 marks for the second factorising as well. Okay, so sorted. Nice one.